So in this question, we are given two complex numbers added. When added gives us I. So using this information, we have to find the value of A and B. So let us begin by adding the two fractions. So we multiply the denominator, so that would be 3 plus I multiply to 3 minus I. We are using the butterfly method to multiply the two fractions. So we take the element in the diagonal, which is A minus 1 and 3 minus I, and multiply them together and add it to the product of the diagonal elements of the other diagonal element, which will be B minus 1 times 3 plus I, and this value is equals to I. So let us do the multiplication. So we have twice A minus I times A minus 3 plus I plus twice of B plus I times B minus 3 minus I whole divided by 3 squared minus I squared, and this value is equals to I. Now we combine all the real terms. So we have 3A added to 3B, and we have negative 3 and negative 3, so that will become negative 6. So this is the real term plus I. So we have one positive I and negative I, so that is going to cancel out each other, and we have B minus of A. This will be divided by 3 squared, which is 9, plus 1 equals to I. Therefore, we have 3A plus 3B minus 6 divided by 10 plus I times B minus A divided by 10, and we're going to write I in the standard form, so that will be 0 plus I times 1. So with this is based on the equality of two complex numbers. So we equate the real part with the real part, so that would give us 3A plus 3B minus 6 over 10 equals to 0. Solving for this, we get 3A plus 3B minus 6 is equals to 0. Dividing both sides by 3, so that gives us A plus B minus 2 is equals to 0, and we have A plus B equals to 2. So let this be the first equation. Then we equate the imaginary part, so we have B minus A divided by 10 is equals to 1. So this gives us B minus A is equals to 10, and we have B is equals to A plus 10. So let us substitute the value of B, which is A plus 10, into equation number 1. So that becomes A plus, so instead of B, we are writing A plus 10 equals to 2. So we have twice of A equals to 2 minus 10. So that would give us twice of A is equals to negative 8. So we have A equals to negative 8 divided by 2, which is negative 4. Now, so solving for B, so we have B is equals to A plus 10, so that would be negative 4 plus 10, which is equals to positive 6. So therefore, we have the required value of A and B. So A is negative 4 and B is positive 6. Let's go to the next question. So in this question, we have to find the value of A and B. So let us begin. So we have 2 times root 3 multiplied to cosine of 30 degrees. So cosine of 30 degree, this value is square root of 3 over 2 minus 2i times sine 30 degree, and the value of sine 30 degree is half, divided by square root of 2 multiplied to cos 45 degree, which is 1 over root 2 plus I times sine over 45 degree is also 1 over root 2. And this value is equals to A plus IB. Now we simplify it, so the 2 and 2 gets factored out, this 2 and this 2 as well. And that finally gives us root 3 times root 3, which will be 3 minus I divided by, so root 2 times 1 over root 2 will be 1 plus I. So this is the value of A plus IB. Now we have to write the complex number on the left hand side in the standard form. So let us do that. So to do that, we are going to multiply the numerator by the conjugate of the denominator, and also the denominator by its conjugate, and this is equals to A plus IB. So let's move on to the other side of the page. So we have 3 minus I multiplied to 1 minus I, so that would be 3 multiplied to 1 minus I multiplied to 1 minus I divided by 1 squared minus I squared, which is equals to A plus IB. This gives us 3 times 1 is 3 minus thrice of I minus I times 1 is negative I plus I squared divided by 1 minus of negative 1, which is equals to A plus IB. So this gives us 3 minus 4I minus 1 divided by 2, which is equals to A plus IB. So we have 2 minus 2I divided by 2 equals to A plus IB. So we'll write in the standard form, this will be 1 plus, I made a mistake here, so this is 4I. So we have 1 plus negative 2 times I is equals to A plus IB. So since the two complex numbers are equal, so this gives us the value A equals to 1 and B equals to negative 2. Let's move on to the next question. It is given that the product of A plus IB to 2 minus 3I gives 4 plus I. So we have to find the value of A and B. So what we're going to do, we're going to divide both sides of the equation by 2 minus 3I. So that leaves us with A plus IB is equals to 4 plus I divided by 2 minus 3I. Now we are going to multiply the numerator, which is 4 plus I, to the complex conjugate of the denominator, which is 2 plus 3I. Then we have to repeat the procedure in the denominator as well. So we multiply 2 minus 3I to 2 plus 3I. This is equals to 4 times 2 is 8 plus 4 times 3I is 12I plus 2 times I is twice of I plus 3 times I will be 3I squared divided by 2 squared minus 9I squared. 3 squared is 9. So we have 8 minus 3 plus 12 plus 2 is 14I divided by 4 plus 9, which gives us 5 plus 14I divided by 13. So finally we have A plus IB is equals to 5 over 13 plus I times 14 over 13. Now since they're equal, we equate the real part and the imaginary part. So the real part of A plus IB is A, and that will be equals to 5 over 13, and the imaginary part B will have the value of 14 over 13. So these are the two values of A and B. Let's move on to the next question. This question is very much similar to the previous one, so we have to find the value of A and B. So to do that, we're going to divide both sides of the equation by 1 plus I, so that gives us 2 minus 5I divided by 1 plus I. Then we multiply both numerator and denominator by the complex conjugate of the denominator, which is 1 minus I. So we have 1 plus I times 1 minus I in the denominator. Now we find the product of the numerator, so that will be 2 minus 2I minus 5I plus 5I squared divided by 1 squared minus I squared, which is equals to 2 minus 7I minus 5 divided by 1 plus 1, which is finally equals to negative 3 minus 7I divided by 2. So we write it down in the standard form. That gives us a plus ib is equals to negative 3 over 2 plus I times negative 7 over 2. Now equating the real part and imaginary part gives us a equals to negative 3 over 2 and b is equals to negative 7 over 2. Let's move on to the next question. So we are given an equation. We have to find the value of a and b. So let us begin by first rewriting the given equation. So we'll have 1 plus I divided by 3 plus I whole multiplied by a minus 2I divided by 3 plus I plus 2 minus 3I divided by 3 minus I multiplied by b plus I divided by 3 minus I, and this is equals to I. Now we are going to convert each of them into the standard form. So let's begin with 1 plus I divided by 3 plus I. So we multiply the numerator by the conjugate of the denominator, which is 3 minus I, and we do the same thing to the denominator. So we have 3 plus I multiplied to its conjugate, which is 3 minus I. Now we multiply the two complex numbers in the numerator, so that would be 1 multiplied to 3 minus I plus I multiplied to 3 minus I will be 3I minus I squared divided by 3 squared minus I squared, which is equals to 3 minus y squared will be plus 1 plus 3i minus I would give us twice of I divided by 9 minus of I squared, which is negative 1, so we have plus 1. So that gives us 4 plus 2I divided by 10, and writing in the standard form we have 4 over 10 plus I times 2 over 10. Now we consider the second one, which is 2I over 3 plus I, and we convert into standard form. So we multiply 2I to 3 minus I divided by 3 plus I multiplied to 3 minus I. So in the numerator we'll have twice I times 3 will be 6I minus 2I times I will be 2I squared divided by 3 squared minus I squared, which will be simply equals to negative 2 times I squared will be positive 2 plus 6I divided by 3 squared minus I squared would be 9 plus 1. So finally we have 2 over 10 plus I times 6 over 10. Now we work on the third term, which is 2 minus 3I divided by 3 minus I. that will be equals to 2 minus 3i multiplied to the conjugate of the denominator, which is simply 3 plus I, divided by 3 minus I times 3 plus I. And that gives us 2 times 3 plus I will be 6 plus 2I minus 3i times 3 will be 9i minus 3i times I will be 3i squared, divided by 3 squared minus I squared. So this will be equals to 6 minus 3i squared will be plus 3, and plus 2i minus negative 9i will be negative 7i, divided by 3 squared is 9 and I squared is negative 1, so negative of negative 1 will make it plus 1. So we have 9 minus 7i divided by 10, which will be equals to 9 over 10 minus I times 7 over 10. Then for the fourth term, we have I over 3 minus I, which will be equals to I multiplied to the conjugate of the denominator, that is 3 plus I, divided by 3 plus 3 minus I times 3 plus I. We have I multiplied by 3 will be thrice of I, plus I times I will be I squared, divided by 3 squared minus I squared, which is equals to 3i minus 1 divided by 9 minus of minus 1, and that gives us negative 1 over 10 plus I times 3 over 10. Now let's substitute all this value into our equation number 1. So we'll have 4 over 10 plus I times 2 over 10. So this will be multiplied to A. Minus 2i over 3 plus I, which is simply 2 over 10 plus I times 6 over 10, plus 2 minus 3i over 3 minus I times B, which will be 9 over 10 minus I times 7 over 10 multiplied by B, plus the final term, which is negative 1 over 10 plus I 3 over 10, and this value is equals to I. So let us combine all the real parts together. So we'll have 4 over 10 times A added to negative 2 over 10 plus 9b over 10 minus 1 over 10. So this will be our real part plus the imaginary part, which will be I times 2a over 10 2a over 10, then minus 6 over 10 and minus 7b over 10 plus 3 over 10 equals to I. So we have 4a over 10 plus 9b over 10, and negative 2 over 10 minus 1 over 10 will give us negative 3 over 10 plus I times 2a over 10 minus 7b over 10 and negative 6 over 10 plus positive 3 over 10 will give us negative 3 over 10 equals to I. So we have 4a plus 9b minus 3 over 10 plus I times 2a minus 7b minus 3 divided by 10 equals to I, and it can be written as 0 plus I times 1. Now we're going to compare the real part with the imaginary part. So that should give us the real part, which is 4a plus 9b minus 3 divided by 10 is equals to 0. So we have 4a plus 9b minus 3 is equals to 0, and that gives us 4a plus 9b equals to 3. Let this be equation number 2. And we compare the imaginary part, so that gives us 2a minus 7b minus 3 divided by 10 is equals to 1. So we have 2a minus 7b minus 3 is equals to 10 times 1 is 10. So we have 2a minus 7b equals to 10 plus 3, which is 13, and let this be equation number 3. Now what we do, we take equation number 3 and then multiply throughout by 2. So that gives us 2 times 2 is 4a minus 2 times 7 is 14b equals to 2 times 13, which will be 26. Then we consider equation number 2. We have 4a plus 9b equals to 13. Now we're going to subtract. So on subtracting, the 4a and 4a cancels out. So we have negative 14b. So we're going to subtract. So negative 14b minus 9b is going to give us negative 23b. And 26 minus 13 is a mistake. This is not 13, this is simply 3. So let me remove it. This is simply 3. So we have 26 minus 3, which is positive 23, and that gives us b is equals to negative 1. So now that we have the value of b, let us substitute into equation number 3. So we have 2a minus 7 multiplied to negative 1 equals to 13. So we have 2a plus 7 equals to 13. 2a is equals to 13 minus 7. So 13 minus 7 is 6. So that gives us the value of a to be equals to 3. So we have a equals to 3 and b equals to negative 1. Let's go to the next question. So here in this question we have to determine the value of a and b for the given equation. So let us cross multiply. So that leaves us with a minus 2 plus I times b minus 3 is equals to 1 minus 3i times 1 plus I. So we have a minus 2 plus I times b minus 3, which is equals to 1 plus I minus 3i minus 3i squared. So we have a minus 2 plus I times b minus 3 equals to 1 plus I minus 3I plus 3. We have a minus 2 plus I times b minus 3 equals to 4 minus 2I. Now we compare the real part and the imaginary part, so that gives us a minus 2 equals to 4, which gives us a equals to 6, and b minus 3 is equals to negative 2, which gives us b equals to 3 minus 2, and we have b equals to 1. So these are the two values of a and b. So in this question we have to find the value of a and b. So let us rewrite the given equation as 3a minus of I times 2b is equals to 10 plus 10I divided by 2 plus I whole squared. Now we're going to expand the denominator, and that gives us 10 plus 10I divided by 2 squared, which is 4, plus 2 times 2I, which will be 4I, plus I squared. So we have 10 plus 10I over 4 plus 4I minus 1, where we have replaced I squared by minus 1. We have 10 plus 10I divided by 3 plus 4I. So this is 3a minus I times 2b. Now we have to convert 10 plus 10I divided by 3 plus 4I into a plus ib into the standard form. So let us do that. So we'll have 3a minus of I times 2b is equals to 10 plus 10I multiplied by the conjugate of the denominator, which is 3 minus 4I divided by 3 plus 4I multiplied to its conjugate, which is 3 minus 4I. Now we multiply the two complex numbers in the numerator, so we have 10 multiplied to 3 minus 4I. So 10 times 3 will be 30, minus 10 times 4 will be 40. So we have 40 times I plus 10I multiplied to 3 minus 4I gives 10I times 3 is 30I minus 10I times 4I will be 40I squared divided by 3 squared minus 4I squared, which is equals to 30 minus 10I, negative 40I, plus 30I gives us negative 10I, minus 40 times negative 1, divided by 3 squared is 9, minus 16I squared. So we have 30 plus 40 minus 10I divided by 9 plus 16, because I squared is negative 1, so negative 1 times negative 16 will make it positive 16, which is equals to 70 minus 10I divided by 9 plus 16 is 25. So we have 3a minus I times 2b is equals to 70 minus 10I divided by 25, which in the standard form will be 70 over 25 minus I times 10 over 25. Now we equate the real part and the imaginary part. So that gives us thrice of a is equals to 70 over 25. Now we can divide both the numerator and the denominator by 5. So that gives us thrice of a is equals to 14 over 5. So we find out a, we divide both sides by 3, so that gives us 14 over 15. Then we have negative 2b is equals to negative 10 over 25. We multiply both sides by negative 1, so that gives us 2b equals to 10 over 25. Then we can divide both numerator and the denominator by 5. So we have 5 times 2 is 10 and 5 times 5 is 25. So that gives us 2b is equals to 2 over 5. which implies b is equals to 2 over 10, or which is simply equals to 1 over 10. So these are the two values. So we have a equals to 14 over 15 and b is equals to 1 over 10.